I think now we'll start recording. Yeah. So, as I said, the last time we have already announced that today we are going to practice what we have already discussed in lecture 4 and lecture 5. Because I believe that in these two lectures, there was a lot of information that need more practice. So this is why, and I believe this is very important for analysis and for system analysis and design, because when I say database, which is the base, so this database, how we can manage it and make a good design, and then how we can enhance it, making a normalization for this. I believe it is a very important topic that I want to be sure that you have already understood and you can know how to practice this. Concerning live sessions, again, I said from the beginning, it is not mandatory. However, I believe that who has time and can join, he should join, because it will be a good opportunity that he will practice exercises and he can ask me a questions. And I believe that if I will register or record, if I'm going to record the lectures by myself, I don't believe it will be very effective like when there is an interaction between the instructor and students. So this is the main aim from the live sessions and motivating you to be in these live sessions. It is not because I need to have it as a mandatory, no. It will still optional, because this course is, from the beginning I said, this asynchronous online course, which means that you will get online materials and expected to do at home your assignments and your exams and your project. However, again, rather than recording this lectures without student, it's better to record it with an interaction with the student. It will be good for who is going to enter this live session, and also who is going to watch the recorded live session. Because sometimes when he or she will watch the recorded session and can listen the interaction and the questions being asked, he can benefit better than having only one speaker and talking about the material. So today we will have two parts of the question. I will start by the last lecture about normalization, and then I will go to the lecture before. So then the first part, we will solve the exercises with each other. And in the second part, there is an exercise, we will do it with each other. And I will keep somehow long exercise as a group work, like always. You can do it. And who is going to be in this group work, he will get some bonus. And then we will return back to the main room and discuss the final result. Before I forget, I finished the assignment 2. And when I finish assignment 2, it will be based on assignment 1. I will publish this after today's lecture. So we expected to have an assignment 2 after today's lecture, because I said from the beginning we will have 4 assignments. And in the first week of the next month, I will publish the project topics. You will have 4 to 5 topics. Each group can choose one of the topic, and then you are going to make the whole procedure that we have learned in this course so far, applying it to a real case scenario. The deadline for the project will be the last week of the semester, so I think it will be the third week in December. However, I will send a guideline for the project. However, you should know that a presentation is mandatory. It doesn't mean that you will have to do a live presentation. The group of students who will be in the same group in the project, they have to record a presentation, the same like we do in the live session, and they have to share with me. They have to share with me the recorded video, because I believe that in a project, I don't expect to have only a deliverable, because students, like for example, an assignment, when I send an assignment, I will can find that students somehow, they have to go to online platforms like Course Here or something else, and they have to submit the assignment and ask somebody else to solve for them. Yeah, they can do this. For me, I have to correct what I have. I will not track how he has this solution, because I will deal with you as a mature. As I said from the beginning, I will be more than like a trainer, more than an instructor. However, for the project, my aim is to see how you can present the idea that you have already generated and the design and the analysis that you have already agreed on it. This is very important for all of you when you go to the market, because the way many people, they know a lot of information, but they don't have a good way to present what they have from information about such kind of topics. So the body language, the way you make a presentation, the organization, how you organize your presentation in a very good logical manner. So this is why and I will give a portion of the grade of the project based on the presentation. So I'm telling you this now in the live session for all who is going to watch again the recorded live session, to know that they are expected to deliver a recorded video presenting the outcome of the project with a text file, whatever it is, Word file, about the delivery of the project. I will write this as a guideline when I publish the topics. Any question concerning the project before we start exercises? So can you give me 2 thumbs up? Okay, perfect. So let's start with the normalization one. So just to revise the normalization, that we have 3 kinds of normalization. We have discussed it the last time, the first, the second, the third. We said normalization is after we have already implemented the database, we are going to double check if our structure is a homogeneous structure, which means we have to be sure that all the attributes that they are talking about the same concept, they are in the same table, and we don't have some attributes that are not homogeneous with the other attribute. This is why we are going to focus more about the relationship of the attribute in the same table. Not like when we start designing the database, we concentrate more or focus more about the relationships between the relations of the table. And we said 3. So the first one is about, to said it is a first normalization, there is no multi-value attribute should be. So if a table has a multi-value attribute, then we said it is not a first normalization. A second normalization, we said that we have to check the non-primary attributes, non-primary, and the primary key attributes. It can be primary key, can be one attribute or more. And the last time, one of you, I forgot whose, he has, or she asked me about the difference between the key and the primary key. I said a key is, we can have different candidate key in the same table, which means that an attribute or set of attributes that will be unique, for example. However, a primary key is the minimum candidate key that we choose it as a primary key. In this case, we have to be sure that all non-key attribute or non-primary attribute should be fully function dependent, which means that will not depend in another non-primary attribute. Should be all dependent only on the primary attribute. And in the third, we said it should be second, if you remember. Plus, there is no transitive dependency, which means that we don't have, for example, that another non-primary attribute depend on non-primary attribute, and then this non-primary dependent on them. They should be all directly dependent on this one. Okay, so let's start with here. I need today so much volunteers, so keep awake. Which form A or B of the following relation is first normalization? Who likes to reply? Just raise hand. So we have two forms for the same table, A and B. Do you believe that A is first normalization, the first normalization standard satisfied here? Yes, no, and also the same for B. Chain. Okay, Andrew, go ahead. Chain, prepare for the second question.
Hello, can you hear me?
Yeah, we can hear you.
Okay, perfect. So I believe form B is first normal form and form A isn't.
Perfect. Can you tell us why?
Because form A has multi-value attributes for choruses.
Perfect.
Okay.
Yeah, thank you so much, Andrew. Yeah, you are correct. Form B is, you can say that it satisfies the first norm, and A doesn't satisfy this because A had a multi-value attribute. You are 100% correct. Let's go more. So suggest suitable key for B. Which one you think that it is a key, can be a key. It may be one of attribute or more than one of attributes. So it can be set of attributes. And what is the functional dependencies that hold? So what functional dependencies we have here? Okay, any volunteer or I have to choose? Don't be shy. So I don't expect that all, we are not in an exam, so we practicing exercises. So I don't expect that all of you know the answer. So, okay, Misal, go ahead.
Hello.
Yeah, hello, we can hear you.
Yeah. I think student ID can be used as a primary key, and I think the advisor will be the functional dependency, because if advisor is removed, then the advisor office will also.
Let's go one by one. Let's go one by one. Why?
Oh.
Yeah, I agree. Why you choose student ID as a key?
Yeah, because a student can be uniquely identified as a student ID. There won't be duplicates in student ID.
Perfect. So, for example, the causer is duplicate, you mean?
Yeah.
Okay. Perfect. Okay, so student ID, you can see that this student ID, whenever it has to change, that all the attributes should be changed in this case, or one of the attributes, or one of the other attributes, which means that we can see 122 that is Ali block B 440, and then we said that 1022 we will have, for example, Pierre block B 440. This is why you choose a student ID. Do you agree?
Yeah.
Okay. So now what about functional dependencies?
Okay, I think because like if the advisor is removed, then the advisor office also gets, it depends on the advisor. So I think that's one.
So I didn't get it. So what is functional dependency mean X give Y? So you should tell me who will be in the left part and who will be in the right part.
Okay.
You got it?
Yeah. So the advisor will be the X, the left part, and the advisor office will be the right one.
So advisor give, advisor office. Can you tell us why you choose this?
Yeah, because I think it's because if the advisor office only exists if the advisor is actually there.
It only exists if the advisor is here. So which means that, okay, so can you define for us what your own understanding for functional dependencies? I'm just asking this question to be sure that you get the concept in the correct way. So are you okay in asking you this question?
Yeah, sure, no problem. I'll try.
Okay.
Yeah, it's like you said, like x to y. So I think the removal of x removes y. So in this case, like if advisor is not there, then the advisor office is also not there. I think that's
okay. First, this is a two dependencies that we have it here. The first one, perfect, as you said, but let me redefine it in a better way. It's not only about the removal, about when you talk about removal, let's talk about, when I talk about the X part or the left part in this dependency is like the one you talked about it, advisor office. So which means that the value in this X is related to only one value from the Y side. So if, for example, Pierre block A, if you have a Pierre block B, so now we can say there are function dependencies. Because the left part should be only to related one and only one for the right part. And here this is satisfied, which means that we have two values in the left part, Ali and Pierre. So Ali, we have, for example, Ali block B, block B, block B. Whenever we have Ali, it's always related to block B. If we will have two lines, Ali block B, and then we'll have a third line, Ali block C, now we can say there is no function dependencies. Because to set that X related to Y or Y dependent X, this means that X is related to one and only one value from the Y side. So what you said is correct, but I am redefining the reason why you said there is a function dependency. Is it clear?
Yeah, thank you.
Let's go ahead, stay with me, Misan. So let's go ahead, student ID and advisor office. Student ID here.
Yeah.
Sorry. So 1022 from advisor office and advisor. So 1002 is related to two value, Ali and block B. So always 102 is related to these two values. Let's go to another value, 4123. Is always related to Pierre and block A, Pierre and block A, Pierre and block A. This means that the values in the X side is always related to only one value from the Y side. Here the Y side is advisor and advisor office. So we have two attributes on the Y side.
Yeah.
So we can say that this is, we have this two function dependencies so far. The last question for you, sorry, Misan, for this.
Yeah, no problem.
I'm just asking this question, make this interaction between me and you, that all of us can understand more the concept. Why you are searching for the function dependencies? Why? Why?
Could you repeat the question?
Yeah, I said my question is why we are searching for the function dependencies while we are considering them. What is the need from the function dependencies?
I think it's because, like, in case, like in normalization, like suppose in case we like we break it down into like smaller, like smaller
100%. Like, let now not to go so far about how we deal with normalization. So first, when we talk about normalization, we have to be sure this structure satisfies this level of normalization. Yes, no. Then we will go to the next step to make the composition to go ahead and to be sure that the rule now is being satisfied. However, from the definition that we talked about it, about what we mean by normalization, we talked about to see or to examine or to check that these attributes in the same table, they are somehow homogeneous. So do you believe that these function dependencies give us an image about the relationship between the attributes?
Yes, I do. I think it helps us like understand the actual relationship.
Yeah, this is a point. So the ER diagram before give us an image about the relationships between different entities. However, the functional dependencies give us an image about the relationships between the attributes themselves in the same table. So having these relationships and representing these relationships will help us to go ahead and see the normalization rule are satisfied here, yes or no. So so in this case, these function dependencies that represent the relationship between attributes, they will be an input for the normalization analysis. Do you agree?
Yes.
Perfect. Thank you so much.
Yeah, thank you.
So guys, this kind of interaction, what I'm doing with each one of you, is just to clarify the concept and to practice this. It is very important that all of you can do it. So this is why don't be shy now that you can interact with me and and answer the question. There is no grace, and I will be very glad to help you to understand more the concept. Let's go more. Okay, so next, based on the function dependencies that we have this function dependencies in this table. So we have two so far. Advisor give advisor office, we have here this, and the student give advisor office and advisor. Let me here go ahead and write it like here. So advisor will give here like advisor office, and we have one between advisor and advisor office. And don't forget that we agree that student ID is the ID for this table. However, student ID, that I forgot to tell you this about Mason, that when we talk about student ID as standing alone, here as an ID, this table, if we go about 122, there is duplication here. We forgot to discuss this. So for this table, we agree we should have this two in this case. 102,440, 102,412, 102,415. So if we choose these two, we can have a key without duplication. But however, this student ID, we will have a duplication. I forgot this to discuss it with you, just I'm discussing now. Are you okay, Mason?
Yep, I've got it.
Okay, so the function dependency, we have this one, I name it FD2, and here this we have an FD1. And these two attributes are the key for this table. Now, oops, wait. Now you can see the answer. I can see this. I have to. I have to wait. Give me just 1 second. I have to add animation for this. Okay, we were here, I think so. Yeah, we finished this. Yeah. Again, we thought that this is a key and this is a key. Why? Because both of them can make a uniqueness key. You never have a duplication in the table for both of them. For each one of them, you can have a duplication, but for both of them, you cannot have a duplication. So, and the FDs will be, we will have an FD between student and advisor. Student ID give advisor and advisor office. And we have another one between advisor and advisor office. So now the question is, do we have a second normalization? Yes, no. If no, we are going to decompose it in a way to have a second normalization. So who will be the next volunteer? Sorry. Can I choose? Okay, Shane, go ahead. Perfect.
I think that the relation here does not have second level normalization because there are repeating values.
Repeating values? What do you mean?
Or
repeating values?
sorry, there are the primary key attributes are repeating.
No, we can't say it is a prime. Oops, sorry. What's happening here? What's this? Just open again. So, Shane, first, when we said when we are going to say that this set of attributes, they are primary key, this means that there is no duplication, or we can't say it is a primary key. Do you agree?
Okay, yeah, I agree.
So student ID and course, both of them form the key, which means that you never find the same two values that come again in the table. So you can see now 1022,440. You never will find 102440 again. However, maybe you can have 1022 as standing alone again, because student ID, this is what I said for Mason now, student ID as a student ID standing alone will not form a key in this case, based on this table. So we have already agreed on the primary key. The question now about second normalization. Second normalization, can you define it to me again? What do you mean by second normalization, to be sure that you get the concept in the correct way?
Yeah, I'm assuming that I have it wrong now because of how I answered. But from what I remember, the second normalization was that you cannot have any duplicate attributes.
No. I will give you a hint. In second normalization, you have to go ahead and double check the relationship between the non-primary attribute and the primary attribute. Who's a non-primary and who's a primary attribute here?
The primary attribute is the student ID and the course.
Perfect. Non-primary one?
Advisor and advisor office.
Perfect. So I will give you another hint now. So according to the definition of the second normalization, the non-primary attribute, they should be fully function dependent on the primary attribute.
Right. Okay.
So do you know what I mean by fully function dependent?
So if the primary attribute, each primary attribute should...
No, I will give you another, I will repeat the definition for you. When I said that this table or this relation satisfies the second norm, it means that all non-primary attributes, they are fully functional dependent on the primary key or attributes. Now the question, what do you mean by fully function dependent? Do you know?
The non-primary attributes are dependent on the primary attributes. So
they should be dependent on the primary attribute. Or normally to say this is a primary attribute, that this means that it is unique and all non-primary attribute dependent on it. This is normal, or it cannot be a primary attribute.
yeah.
But to say it is second normalization, there is a key word, fully functional, not only functional dependent, fully functional. So now the question is, what do we mean by fully functional dependent? Normally, when we said this is a primary attribute, it means that all non-primary attribute dependent in it. This is normal. However, to say it is second normalization, all non-primary attribute should be fully functional dependent, not only function dependent. So the question now said, what do you mean by fully function dependent? Do you have an idea?
I don't.
Don't worry. So you don't have an idea what you mean by fully function dependent in this case?
No.
Okay, I will give you another hint. Don't worry. So now the primary key that we agreed on, it is student ID and course, yeah?
Mm-hmm.
So it is two attributes.
Right.
Okay, so to say it is a fully functional dependent, not only function dependent, which means that all non-primary attributes should be, or they are dependent in both of these attributes, not part of these attributes. Again, when I said that second normalization means all non-primary attributes, they are fully functional dependent on the primary key. This means that all non-primary attributes, they are dependent in the whole attributes of a key, not only on a part of this.
Yes.
So to say it is a fully functional dependent means that advisor will depend on the student ID and course.
Yeah.
Advisor office will depend on the student ID and course. Advisor cannot depend only in student ID only or in course only. They should depend, advisor should be dependent on both of them at the same time.
Yeah.
This is what we mean by fully functional. So this fully word comes from the whole primary key, not in a part in this primary key.
Okay.
This is why we said second normalization, it is fully functional. It is not like the third one. We will talk now again about the third one when we talk about transitively. So again, I repeat it the last time, second normalization means that all non-primary attributes are fully function dependent on the primary attribute. This means that all non-primary attributes should be dependent in the whole attributes of the key, not only on a part of it. So if this rule is satisfied here now, Shane, yes, no?
No.
And if no, why? Why?
The student ID and course primary key for the 1022 and 440 have the same non-primary attributes that the primary key 1022410 have. They have the same advisor and advisor office.
Yeah, but again, when you talk about second normalization, you have to double check the functional dependencies. What is the functional dependencies that we have it here?
The ones that we just talked about earlier, right?
So can you tell me again, what is the functional dependencies that we have it here?
Yeah, the advisor and advisor office.
Well, functional dependencies always read it from left to right, from X to Y.
Yeah, the student ID X,
Okay.
and the advisor and advisor office Y.
Student ID gives us.
Okay, yeah, the student ID gives us.
I said advisor, I will write it A, and advisor office, I will write it AO.
Yeah.
So student ID gives us advisor and advisor office.
Yeah.
So, and we have an advisor give us advisor office. Okay?
Yep.
So again, when we talk about fully functional dependent, which means that now the A and AO, the advisor and advisor office, depend on student ID. According to the rule of the second normalization that we have already discussed so far, all non-primary attributes should be only dependent in the whole key, which means that this is violate the second normalization, because a primary attribute, a non-primary attribute like advisor and advisor office cannot depend on only part of the key. It should depend in the whole part. It should depend in the student ID and course at the same time. It cannot be dependent on only a part of this key. So this is why whenever we have only one dependent, function dependent, that violates the rule, no need now to go further and see other dependencies. We can say that now we don't have a second normalization. So whenever we have only at least one of the dependencies violate the rule, then we can say that now we don't have a second normalization. So we don't have a second normalization because A, advisor and advisor office depend on student ID, or student ID give advisor and advisor office. And based on the definition of the second normalization, all non-primary attribute should only dependent in the whole, fully, in the whole key, not on a part of this key. Is it clear now, Shane?
Yeah, you've made it really clear.
Okay,
Thank
perfect. Now, wait, I still need you. So we said it is not second normalization. So we need to decompose it in a way to have it as a second normalization. Can you suggest any decomposition in order that the outcome of the decomposition will be a second normalization? Again, who violate the rule? Which attribute violates this rule? The advisor and advisor office, yeah?
Yeah.
Because they are related to student ID. What about if I will take this as a table and have these two as a table? So I will have a table that has a student ID, advisor. I'm sorry. I will have a table that have a student ID, advisor office. And I have another table that have a student ID and course. What do you think about this?
I think that works.
Okay, so I can do it like in this case. Here we have now in this table we have only this. We can choose the student ID only as a key, and so in this case this gives this. Both of them dependent on a one key, and here also we can have, for example, maybe the course or the student ID, whatever, as another key. So having these two tables, now the attributes in this table fulfill the requirements for the second normalization. Do you agree?
Yep, I agree.
This is the main aim. Thank you so much, Shane. Really, you helped me to clarify the idea, because without you it will be tough. It will be so tough that I can clarify this idea. Based on this conversation with me and you, we clarify it to you and for the others in this case.
Yeah,
so
thank you.
For you. So again, I know that sometimes it's not easy. You can imagine how we are analyzing this relationship, but this is the main aim from today's exercises. Now you can understand more, having a real cases to understand more. Okay, so the last question from this. Okay, we have already decomposed it as two tables. We have two tables now, and we have this table. Suppose that this table we have a higher ID, and based on what we have a function dependence between here and there. This is this is the first function dependence, and we have also another dependence here and there. Let's take this table now. This is second normalization. The question now, is it third normalization? Yes, no. Who will be the next volunteer? Don't worry, go ahead. What about you, Kevin?
Can you hear me?
Yeah, I hear you so well.
So what was your question again?
Yeah. So you were following up with us what happened before, yeah?
Yeah, the second normalization. Yeah.
Yeah, so the second normalization is somehow clear for all of us. The second normalization means that all non-primary attributes should be fully function dependent on the primary key, which means that they can't depend only on a part, they have to depend on the whole key. Let's take this table now. So advisor and advisor office depend on student ID. And by the way, when we have only one attribute in the key, it should be automatically second normalization because it doesn't have more than one attribute. So in this case, it will be automatically second normalization because who will violate the second normalization whenever we have a non-primary attribute will depend on only a part. So since it is only one key, only one attribute, so it cannot be decomposed. So all the non-primary will depend in it. In this case, it will be second normalization. Now the question is it third now or not? Do you know what is the definition of the third normalization?
I'm still kind of blur about this third one.
Don't worry, we will redefine it and we rediscuss it now. Third normalization said that the rule says that all non-primary attributes should be fully function dependent. So they should be second normalization first, plus non-transitively, which means that if you have a table X, Y, Z, and W, so you will have these two as a primary key. In this case, Z should dependent on X and Y at the same time, and W and Y and X at the same time.
Okay.
To be a second normalization. The second point, to be third, W or cannot be dependent on Z, because in this case, as if W depend on X and Y transitively, which means that there is no dependency should be between the non-primary attribute. Only the dependency will be one way, from non-primary to primary. Between non-primary attribute, there is no dependency should be. You got it?
Yeah.
So now tell me, this table, does it satisfy the third norm? Yes, no, based on this definition.
I don't think so, because the advisor only have his office, right? So if it's not Ali, then
So let's now go back to what function dependency we have. The first one is first function dependency, FD1.
Yeah.
This is student ID give us advisor and advisor office. The second one, advisor give advisor office. This is FD2. So again, according to the third normalization, first it should be second. This is second, yeah, Kevin?
Mm-hmm. Yeah.
So it is a second normalization. The second condition that all non-primary attributes should not have a dependency between each other, and their dependency should be only in one way to the primary key.
Mm-hmm.
So do we have dependency between the non-primary attributes here?
Yes.
Which one?
The advisor and the advisor office.
Perfect. So in this case, FD2 violates the rule of the third normalization.
Yeah.
Do you agree?
Yeah, agree.
So we don't have a third normalization. In this case, what we can do, make a further decomposition. So this table, we can make a student ID with advisor, and then advisor office. And this table somehow, because it's just two attributes, there is no further decomposition can be done, and it's already satisfied third, second, and third. So finally, we will have now three tables. All these tables satisfy the first, second, and third normalization. Kevin, are you okay?
Yeah, I'm okay.
So if I give you another question, you can solve it?
Maybe. I'm not sure.
Okay, the last point now. Can you redefine again what you mean by third normalization?
So third normalization is non-primary key cannot depend on each other. So it
Perfect.
can only depend on the primary key.
As a whole.
Yeah.
But as a whole, this is from the second normalization. So if the
No,
primary key is
only the just one, partially.
Okay, which means, yeah. So, and my last question for you, Kevin. So if we are going to check if this table satisfies the third normalization rule, do we have first to check it as a second, then we'll go to see third, or we can directly see if it is a third, yes, no?
You have to check it from the second.
So this is the point. So first to say it is a third normalization should be second normalization. So we have to check first if it is a second normalization, and then we have to add another condition that there is no dependency between the non-primary attribute in this case. Thanks so much, Kevin.
Thank you.
You helped me so much. So this is, I think that these 4 different parts give us a good practice for the whole normalizations rule. First, second, third. Anyone has any question concerning normalization? I'm happy to hear your questions. So no questions, I need 3 thumbs up to continue. 3. Always stay here. Perfect. So this is a very quick normalization question. So consider we have a relation R. You have 5 attributes, A, B, C, D, E. I give you the dependencies. I didn't give you the values of these tables, the rows. However, I give you the dependency. So A give B, B, C give E, E, D give A. The question said, list all the keys for R. So you tell me how I can know the key even though I don't have the value of this attribute. Don't forget, a key means that all other attributes depend on it. So based on the function, so this is another way how you can pick a key. Based on what we know so far, we said, okay, we can know the primary key of a table by checking the rows, no duplication, there is a key. However, if you know the dependencies and you know the relationship, that you see that all other attributes depend on this attribute. In this case, we can say this attribute can be a key. And the primary key means that it is the minimum key that we can have. So any idea about the keys for this R? What is the key can be? Okay, let me pick one of Nomi. Are you here? Can you hear us, Nomi? Nomi. She can't hear us. Okay, let's say Riss Liefler. Can you hear us? Okay, I can. Okay, do you have an idea about the solution here? What is the key? So again, we will have in this table, we have A, B, C, D, E. So this is the table. We will have A, B, C, D, E. And you have A give B, and B, C, both of them give E, and ED, both of them give A. What do you mean are not influenced by other variables? So the point that, yeah, so in this case, to see that if you want to pick the C and D means that all other depend on them. So you said CD. So in this case, if we said CD, as you said now, so I don't believe that CD as standing alone can be a key, because not all other depend on them. I will give you a hint. What about if I add CDE? I add E. CDE. Let's double check with me and you. So A depend on B. Okay. And ED, so if we take CDE as a key, if you take CDE as a key, the non-primer will be in this case A, B. So do you agree that CDE can be a key? Yes, no? Again, by mean that when we pick as a key, it means that we can have the other depend in this key. That, for example, we have A and B. A and B, it doesn't mean that they can depend directly. Maybe they can depend transitively. So you said yes. Okay, let's give you that. I believe that CDE, ACD, BCD can be. Why? This is all key. It doesn't mean that a primary key. Primary key can be one of them. Normally, we choose the primary key as the least, let's say, if we have, for example, more than one choices, a key with 3 attributes, another key with 2 attributes, we can say the one that with the 2 attributes, I can choose it as a primary key. So key is the candidate that maybe you will have more than one choice to have a key. However, the primary key should be one of them that you choose. You can choose it from these candidate. It can be one of them in this case. Okay, so why CDE, why ACD, why BCD? Again, that when I said this is a key, which means that others can depend on this in this key in this case. So CDE, because we believe that A depend on B and BC depend on E, so they have some relation between each other. What about ACD? Because we said, so ACD, if we take ACD, then we will have B and E. Again, and ED dependent on A, and BC dependent on ED dependent on A. So in this case, we will have all the other transitively dependent on this key. So choosing the key use a dependency, which means that this key that I choose it, the other can depend on it transitively or directly. I'm not talking about normalization, about talking what is the candidate or how many candidates can I have for such kind of table using the attribute in this case. The second point that is R is third normalization. So considering these as a key, I can see that they are third normalization based on what is the key that I'm going to, because B, E, A are all part in this key. So in this case, so we have all them of the part of this key. So we can say that this is a third normalization. I think somehow this is just a tricky question. The question that was before was more clear because we have more examples based on this. Okay, I will start now. Give me just a second to go. Sorry. I will go ahead now about the ER diagrams. So the ER diagrams now, oh, sorry. Do you want to take a break or we can continue? Yeah, I just have 2 more questions about ER diagrams. So do you need a break or I can continue? If you need a break, I need 3 thumbs up. No thumbs up, I can continue. Kevin, the key for us, sorry, that's me, because I have 1 slide today. I have 1 slide with, this is the one with solution. What's happening here? Okay, no worry, I will explain it without a slide because I'm having more than 1 slide today. Okay, Kevin, the question, I will tell you about this, about the key. First, are you okay that, can you use a mic, Kevin?
Yeah.
Can you use a mic? Yeah. First, do you know what is the difference between candidate key or a key and primary key?
A key is like, I guess, like candidate for primary key. So
Perfect. Yeah, you are correct. So now what is, okay, it is a candidate for a primary key. So what is a primary key?
So X skip Y. So if you
Well,
change the primary key, then you
forget now about dependencies. Forget about dependencies. When I have a table, I have a table here, X, Y, Z, W. So if I have some values here, and you know the values, so if you want to choose a key, and then you can choose a primary key from these keys. So how you can choose the key having the values here? How you can choose it?
I'm not sure.
If you want to double check the values, as what was talking was maybe Mason and Chain, that you are going to see if there is no duplication. If for example, let's take a real example here. You have X here, 1, 2, 3, 4. You have Y here, 5, 6, 6, 7. You have Z here, 8, 8, 2, 1. You have W here, 0, 0, 1, 1. So X can be a key because there is no duplication, it's unique.
Okay.
You got it? Okay. So when we said X, mean that X can give Y, Z, W. Either can give them, both of them can give X and Y, for example, X and W, and can give X and Z, or can give X can give Y, and Y already can give Z. It means that in this case, X gives Z transitively.
Okay.
So if I have to go and talk about primary key and keys, not by double checking the values, by looking at the dependencies, then all the function dependent, in this case, the key is going to give all other non-primary attributes in this case, like I said here. So X should give Y and Z and W to say that this key or this attribute can form a key. You got it?
But in your exercise is like really hard to understand. Like you have so many relation between A and your last exercise.
Can you understand this? If I said, okay, here, I will give you X, Y, Z, forget that exercise. I want you to know the concept now. If I said X, Y, Z, W, and I tell you that X have Y,
Yeah.
and then I said Y have Z, and I can said X give Y and W.
W
Now we
or Z?
Y and W.
Okay.
So X give Y and W, X give Y, and X give Z. This is Y. So you have 3 function dependencies. This is FD1, this is FD2, this is FD3. The first one, X give Y and W. The second one, X give Y alone. And the third one, Y give Z. Without knowing the values now, can you say that X can be a candidate key? Yes, no.
Yes,
Why?
because X basically is like give attribute for every single other. X give
But
Y,
it doesn't
W.
give for Z. It doesn't give for Z.
But transitivity.
Yeah, this is a point. This is a point. So now X can give Y and W and X give Y. However, X give Y and Y give Z. In this case, X gives Z. So I can say that X can be a candidate key in this case because it has a relationship with all other attributes.
Okay.
So a key, it should have a function dependencies of all other attributes. Now, having this transitively relationship, it means that we will not have a third normalization in this case. Because third normalization said if it is a key, the non-primary attribute should not have a relationship between each other, should have only a relationship with the key in this case. So the aim from the exercise before is that using dependencies, we can have a key suggestions, even though we don't have the values. But maybe because we have a lot of, it was a composite key, it was not so clear. This is why I said, go ahead and see this example if you can understand it from here.
Okay.
Are you okay?
Yeah. Thank you.
Perfect. Anyone more have a question? I need 3 thumbs up. 3. Shane, Kevin, and I need more 1 thumbs up because Kevin has already answered the question. Okay, perfect. Now, guys, so I think, do you want to take a break or we can continue? If you want a break, 3 thumbs up. No thumbs up, I will continue. So Mitch won. So thumbs up means that we will take a break. Okay, so I will count till 10. So if I get 3, then we will take a break. 1, 2, we have already. Okay, so it is 11:09. 11:09. We will back 11:20. So 11 minutes. 11:20, we are going to solve 2 ER diagrams. We need almost 30 minutes to 40 minutes. I will keep the session, just I will turn off my camera and my mic. I will be back within 10 minutes, okay? See you. Hi. You are back. So I need 4 thumbs up to start, to be sure that most of you are here. Kevin, Shane, Numi, Mithun. Okay, thank you so much. Okay, let me share the question that we. You can see my screen, yeah? Give me just 1 thumbs up. Perfect. Okay, the question says that you have this ER diagram. We said when we talk about ER diagram, either I will give you the requirements of the project, and then you are going to make the conceptual data modeling, the ER diagram. And then in the design, we are going to transfer this ER diagram to logic design a database schema, or we name it as a simple way, relation database schema. And we discussed this the last lecture. So you have this one. You have 4 entities. When we talk about ER diagram, we will not name it table. We name it entities because maybe we'll have more tables when you go to transfer this. So we have a student, course offering, instructor, course. So student, maybe it will be enrolled in, just I think, yeah. Student, it is enrolled in a course. You know that course, it is a course. Like here, for example, CIS 270, this is a course. And it has a course number, CIS 270. It has a course description, syllabus, whatever it is. And there is each semester for each course, we can have 1 offering or more based on how many sections we will have. And the student will register in a special section or a special course offering. So the course offering, we will have a year, semester, time, section, number, room. And we have another table for the instructor. We have instructor ID, name, department, title. Student, we have a student ID as a key, and the course, we have the course number as a key. Instructor, we have instructor ID, and the course offering, it doesn't have any ID so far. Firas, are you here? Firas, can you hear us, Firas? He's not back. Okay, who's? I think that Mitch. Mitch, can you hear me, Mitch? Mitch, Mitish, I think your name is Kanji Bey, Mitch Kanji Bey. Can you hear me? He's not here also. Okay, so Mithun we have already done. What about Wu? Xinyan Wu? Xinyan, are you here?
Yes, I'm here.
Perfect.
Perfect.
So the question said that we are going to transfer the ER diagram to a relational schema or database logic schema. So do you know what is the steps that we have to do it? Xinyan?
Country not obvious.
Sorry, what you said? Can you repeat?
No obvious.
Not obvious for you. You don't know what. Okay, let me help you. So first, we have to go to check what strong entities we have. Here, this is weak. We discussed before what mean weak, and we will repeat now. So first, we have to go and see what strong entities we have. We have student, instructor, and course. So we will create a table for student. It will have student ID, name, and program. And then we will make a table for course. It will have the attribute. And then we will have table for instructor.
Yeah.
Then we will go to the weak entity. This is weak. Do you know what is weak entity?
No.
Weak entity means that this entity, we can't create a key for it. We can't. So
Cannot.
because, yeah, based on the attributes that we have, we cannot have a key for this. Why? Course offering has a year, semester, time, section, room. For example, here we said for this course, CIS 270, we said we have a section ON, for example, on line 1. And we will have a semester and time and room. However, without having the course number, because if I said ON1, there is a lot of courses that they have ON as a section 1. However, I will have to say CIS 270 plus ON1, which means the section and the course name. However, the course name or the course number, we don't have it here. We have it here in this table. So it is a weak one because we can't create a key from the existing attributes that we have here. In this case, when we go to the course offering as a table to transfer this to a table, we will put all the attribute here, plus we will pick the ID, the primary key of the table that depend on it, and add it here to be part of the key of this table. So the course offering key will be the course number, like CIS 270, plus the section number, plus the year, plus the semester. Is it clear, Ziwan? Zinian Wu?
Oh yeah.
I'm saying your name correctly.
Oh yeah, this time is correct.
Zinian Wu.
Yes.
Perfect. Okay, so now after we finish the tables, we will double check now the relationships that we will have it. We have 3 different relationships. Do you know what is this? It should be like this here. Do you know what is this?
Oh
Many
yes.
to many, one to many. What's this?
It is
Is it
necessary.
1 to 1, many to many? Yeah, go ahead.
This signal is necessary for a student and the course offering and relation between them.
Yeah, so is it, I will give you 3 choices and choose one of them. I'm not talking about optional or necessary now. I'm talking, is it 1 to 1, 1 to many, or many to many?
Many to many.
Perfect. According to the rule, whenever it is many to many, we have to create a table for this. So let's see the solution. Okay, discard, I'm sorry. So according to the rule, let's see what, for the table for the student, we create this. For the course, we create this. For the instructor, we create this. Now, for the weak, so we start with the strong. We have 1, 2, 3, 1, 2, 3. What is a 3? It is a course. And then we will go to the weak entity. Here, the weak one. We will add all the attribute here. And we already add the key from the one that depend on it. So the course number we added here. And we will have course number plus section plus year plus semester. We will make now the key for the course offering. And now we will go to the relationship. If the relationship is many to many, then we will create a table for it because it is many to many. We create a table, we named enrolled, and we will add the key from the both tables. So both tables that we have here, the student and the course offering. So student ID, course number, section, semester, year, plus any additional attribute if we will have it here. So this is done. Okay, what about this relationship? This relationship, can you help me, Dini and Wu, tell me what the kind of this relationship, one-to-one, one-to-many, many-to-many? Can you tell me?
Oh, one-to-many.
Perfect. So if we have a relationship one-to-many, do we create a table for it? Yes, no?
Yes.
No. Only if we will have many-to-many, we will create a table for it. If we will have one-to-one or one-to-many, we don't create a table for it. What we will do, that the key of the one we will put in the many, like here. What is the key here? It is instructor ID. So here, we will add the instructor ID to the table course offering in this case. The same scenario here. We will have also one-to-many. So in this case, we have already, because it is weak, we have already done this and added the course number to here. Is it clear?
Yes.
Perfect. If I give you another question, can you help us and solve it? Okay, guys, the second question, oh, that big one. The second question you are asked now to create a, don't worry, Dini and Wu, it is not for you. It will be group work. So the second question, I give you a real case scenario. It's more like about a medical system or a health system. So like I said, health insurance system. So in this health system, I'm giving you the requirement. You are asked now to build the ER diagram. Let's first discuss, and then we will go to two different rooms. You will make internal discussion, try to figure it out, and then we return back to the main room and discuss the result. So first, let me discuss with you what is the requirements needed. Patients are identified by a social security number. All of us have a social security number. For each patient, the name, the address, and the age must be recorded. Maybe here in Canada you will have a social security number and we have a health insurance number. So suppose that they are the same now in this exercise. Doctors are identified by also a social security number. So doctors also have a social security number. And for each doctor, the name and specialty and the year of experience must be recorded. So in your system, you are going to save all this attribute for the doctors. For each drug, the trade name and the formula must be recorded. So you are going to record this. Each drug is sold by a given pharmaceutical company, which you know that in the drugs, you will have, now maybe we are not talking about the generic drug, we talk about non-generic drug. So in this case, you will have for this drug, a company that manufactures this one. So we assume that all the drugs here, they have a manufacturer company. It is a pharmaceutical company. And the trade name identify a drug uniquely from among products of that company. So a company will produce different drug, and each drug has its own trade names. You know that trade name differ from the formula name, for example. So, and this company will not have the same trade name, or will not have two drugs with the same trade name. And if you want to identify a drug, you said this drug, you give a trade name plus the trade name from the company plus the company that has to do it. If a pharmaceutical company is deleted, you need to keep the track of its product. You need not keep track of its product any longer. Each pharmacy has a name, address, a phone number. Every patient has a family doctor to consult, but maybe get prescription from other doctors. every doctor has at least one patient. Doctors prescribe drugs for patient. A doctor could prescribe one or more drugs for several patients, and a patient could obtain prescriptions from several doctors. Each prescription, has a date and a quantity associated with it. Each pharmacy sells several drugs and has a price for each. Drugs can be sold at several pharmacies, and the price could vary from one pharmacy to another. So I'm giving you full requirement for a health system. What is needed now to create the ER diagram for this one? Can we go to the break you down to 2 room and you start with it? Are you okay? I need 3 thumbs up. Kevin 1, Andrew, Firas, Shane, perfect. Okay, I'll stop sharing now, and I will see you now each one. I will share with you the presentation, and see you now each one. I will see you now in the private room where you are going to discuss internally. Let me first and also stop recording, and then I can merge it later. Now we are again. Yeah, go ahead.
Yeah. Just 1 second.
Take your time.
Sorry, just 1 second. It's gonna.
No, take your time.
Yeah, I'll just share the screen. Yeah, is this visible?
Yeah.
Yeah.
Yep.
So is it finished, or still there's something missed before you start?
Do
you believe this is the final one?
No, it wasn't complete actually, but we were still working on. Yeah.
Go ahead, Noe. Yeah.
Okay. We created like each entity for. Sorry, we created like each attribute for each entity.
Yeah.
And
Let us first start with the main entity that you have. So.
Which is doctors and patients.
Yeah. Yeah.
Yeah. Since they said that like each.
So we have doctor, patients, drug, pharmacy. So we have 4 main entity.
Yeah.
Okay.
Each of them have like IDs within them. The patients have like the.
So doctors has a doctor's social security number. Drug, you choose the trade name and the company name.
Yeah.
And the patient has the social security. What about the pharmacy?
I was thinking that like it would have been named if it's having like an ID. Like ID should.
Yeah, you can't create an artificial key if in your system there is no way to create it. For example, when we create an artificial ID for the student when they come to the university system will generate these IDs, so we can have an ID, like the social security number. The government will generate this, but according to the requirement that you have it so far, is there any party will take care for generating a pharmacy ID?
Sorry, could you repeat the question?
Yeah, sure. I said that you told me now you can have a pharmacy ID, yeah?
Yeah.
My comment on this, that we can have an artificial key like student ID. Student ID, we can add it to the student table because the university system will generate the student ID. So we can say that the student table will have a student ID as a primary key. Here, because in the requirement, they told us that there is something we name a social security number that will be given by the government. We can use it as a key because this attribute can exist or can be generated. However, in the requirement, they didn't tell us that there's something you name it pharmacy ID. So we can't add this because it's not mentioned in the requirements. We can't add an attribute in the system and we don't sure who is going to take care for this or who's going to generate this ID. You got my point?
Yeah.
So I think in this case, I believe that pharmacy, we can choose the name and address because you will never have two pharmacy names with the same address.
Yeah.
So I think that name and address can form a key for this pharmacy. Do you agree?
Yes.
Okay, go ahead.
Then for the relation between patients and doctors, it said that a doctor can have like multiple patients, but like every patient consults with one doctor, but can get prescriptions from like another doctor for a drug. So that's why we like put this prescription. Like,
Prescription, it is a multi-way relationship. So it is a relationship between how many entities?
3. Okay.
3, which was, can you tell me because it's not clear in your diagram?
Doctors, patients, and drugs.
Perfect, I agree.
Oh, okay.
And it is many to many between all of them?
Yes.
So patient can have more than one prescription from the same doctor, and this prescription can have more than one drug stated in it. So it is many to many relationship in this case.
Yeah.
I agree. Okay, now the question that if there is no relationship between the patient and doctor?
We use this like sometimes we use this double, like the double line because of sorry. I suggested that we use like the double arrow between like patients and doctors to show that every patient.
So first, let's agree on this. Do you believe that there is a relationship between patient and doctors according to the requirement? Yes, no?
Yes.
Yes.
Yeah.
So there is no?
No, I said yes.
Okay. So there is a relationship between 3 entities, doctor, drug, and patient, and there is a relationship between doctor and patient alone. Okay. This relationship, it has one-to-one, many-to-many, one-to-many. So what is the cardinality type for this? Let me, let's return back to the requirement. Requirement said that each patient had a family doctor. Doesn't say that he can have more than one doctor to consult, but maybe get prescription from other doctors. So each patient has a family doctor, but he can go, for example, to different walk-in clinic and get prescriptions from them. So the one that talk about prescription, you have already finished this because you made a relationship for prescriptions that between doctor and patient and drug.
Mm-hmm.
I think there is another relationship that is a family doctor. That me as a patient can have only one family doctor, registered one family doctor, but I can go to different walk-in clinic to get prescriptions. Is it true? According to what they have stated in the requirement. So The prescription, it is a relationship between three entities, many to many, plus we believe that there is a one-to-many relationship between doctor and patient, because doctor, each patient should have only one family doctor, but we have to give a label. Is a physician for example, or is a family doctor for. So a doctor can be family doctor. Each patient will have only one family doctor, but family doctor can be a family doctor, or doctor can be a family doctor for different patients. So I believe that the relationship should be one-to-many. What the other members in the group, do you agree on this? Shane and Kevin and Mason.
Yeah, we originally have it.
Yeah.
Originally.
Okay, perfect. So thank you so much, Numi and Shane. Let's go to the group 2 to see what they have already done also.
Yeah.
The group 2, maybe we have Andrew and Firas and Shane and Reese Leifer.
Yeah, I think 2 of our guys had to go to another class, but I didn't get. Did anybody get a screenshot of? Because we got pulled out like really fast.
Yeah, I told you before I pulled you out. I told you that you will be pulled out within 1 to 2 minutes. Yeah, but
the whiteboard go?
what you were using? You were using Blackboard? Sorry,
The whiteboard. Yeah.
Yeah. So I think it is still, we still have an access to it. Let me double check. I believe that it will be saved.
Maybe it's saved in that group.
So if you have already used a whiteboard, I can see, I went to the chat whiteboard. Let me see it, loading the whiteboard. I'm loading the whiteboard for this room to see if still saved, yes, no. It is just loading now. Yeah, I have it for you. I will share my screen.
Thank you.
So this was yours, yeah?
Yeah.
Perfect. Go ahead.
Okay. So I don't have the slide in front of me, but so I think the correct name for this relationship between the 3 entities is a ternary relationship, if I'm not mistaken. Yeah. So we have patients, doctors, and pharmacy are all 3 related.
Yeah, but why you made this should be, I'm talking about this. This is a relationship. Why you made a table here? Why you made a weak entity? This is weak entity, what you have already done now.
Yeah. So because there are many-to-many relationships between patients, pharmacy, and doctors, we created a entity to represent that relationship. I think we should have probably came up with a unique identifier for that entity.
Yeah, but wait, why you have to make an entity? You can make a relationship, and you can add, for example, the price and the quantity and the price to this relationship. Why you have to make an entity, and why it should be a weak one?
Oh, okay. Okay, I didn't know that. So you're saying that we can just have the attributes there with no entity?
Yeah, sure, because we said this in the lecture. You can have an attribute for a relationship, and later when you transfer this to a logic design or a relation database schema, if it is many-to-many, you will create for it a table, as we did in the exercise before.
Okay, but you don't include that in the ER diagram.
No need.
Okay.
You can, by the way, you can create an entity here, but I said there is an advice: always avoid weak entities.
Okay.
So if you believe that it would be a weak one because you don't have an ID for it, so get rid about it. Just leave it as a relationship and give it as a name. And you can include the attribute to this relationship, because I think that the quantity and the price, and also as you said, the date maybe, it's somehow related to the relationship. It is not related to the patient or pharmacy or doctor.
Yeah.
It is related to the relationship. So we can create an attribute for a relationship, and later And since it is a ternary many-to-many, we are going to create a table for it. And in this table, as we did before, we will include the all key of the 3 tables, and the keys for the 3 tables will make the key for this table that resembles the relationship.
Okay, awesome. That makes a lot of sense. Yeah.
Okay, so what about the other?
So the pharmacy has a many-to-many relationship with the drugs.
Okay.
And the relationship would represent a sale.
But now there's something, but normally according to the requirement that all the sales should be done like a prescription where the doctor is included. So I think that since we have talked about the relationship prescription, which is a sale, there is no need to create another entity or a relation, let's say, because prescription, when you make prescription patient pharmacy doctor, I think that also, yeah, maybe you have to do it in another way, which means that you still can keep it, but now you make a sale that is something not related to the prescription. I can see this.
Okay, right, yeah.
Somehow it's confused. Because there is overlap between sales and prescription here.
Yeah.
When you talk about sales mean prescription. A pharmacy will not make a sale without a prescription. We're talking about drugs now.
Okay.
Normally, pharmacy can do can sell some drugs from the shelf without prescription, but we are somehow very stuck to what is being described in the requirements. So, since the requirement talk about only drugs with a prescription, so we have only to talk about this operation and this functionality, how we are going to modelize it using the ER diagram.
So in this case, then we could almost just remove the sale entity, and that would work better.
Yeah, but you have to do it another way in this case.
Oh, okay. Because the doctor needs to be related to the drugs.
Yeah, and even though if you keep it, the relationship between drug and pharmacy, you can keep it. I believe that you can keep it. You can keep it at this cell. You can keep it, that pharmacy cell, and you can keep the prescription. I will do the same. However, the prescription should be a relationship and talk about only the prescription, and you can include the date and the price in this because you included the quantity and the cost within the prescription, and the cost is related to the sales. This is what I'm saying about the overlap.
Yeah, okay.
So I think that the prescription will be a relationship that has only, for example, the drug or the quantity and the date. And then we will keep another relationship. It is not an entity. We can do it as a relationship. That this relationship talk about the date and the price that between pharmacy and drug in this case, to not to have an overlap between both of them.
Okay.
And now there is a big question come now. When I have to choose a relationship or as an entity. Because here, for example, the sale, it should be a relationship or an entity. Do you have an answer, Shane?
I would now add that, I mean, we drew it as an entity, but now I would probably say it should just be a relationship. Yes,
this is the point. When you talk about entity, when you talk about ER diagram is something we said conceptual, if you remember, conceptual data modeling. The conceptual, this word came from concept. So the entity will resemble what different concepts we have it in our system. So we have drug, patient, pharmacy, doctor. If there is something based on an operation, this operation is a relationship between different entities. So we resemble it as a relationship because the ER diagram is describing the real world, how it is. Later, when you transfer this ER diagram to the logic design or the database schema, this relationship that's many-to-many, that it can be also, it's going to be a table. So let's keep the ER diagram to be more related to the real world, a more conceptual one, talk about different concepts or entities. What is the relationship? And if we believe that a relationship is based on an operation like cell, and this operation need different attributes. So we can keep it as a relationship. We can add the attributes, and later we can transform this relationship to a table, in the logic design, and later we'll create a physical table as a file in the system in this case. You got it?
Yep.
Perfect. Thank you so much, guys. For me, I will almost do, let me share mine in this case. I have to stop here this. Well, in this case, I will go to this one. So here, this price, talking about cell, maybe I have to add here cell. I was doing, by the way, I was doing with you now the solution. So if I will go here. This is a cell that we were talking about it. Here, this cell one between pharmacy and drug. I believe that also here that the drug will have the trade name and the pharmaceutical company as to give to be the unique ID. The patient has social security number, the doctor has physician social number, pharmacy has name and address. Here we have a ternary one. I put here many or optional because maybe I think that it can be here. And here I believe that we have to put at least one, because according to the rule that they told us, they said that a doctor should have, oh no, maybe we can do it here. Here about, why I said optional, because sometimes it doesn't have to go to a walk-in clinic or get prescription from here, or he doesn't have any, maybe patient will never need to go to a doctor to get a one. So either he will go to different doctor to get a prescription, and maybe he doesn't have any prescription to take it. However, anyone registered in the system must have a family doctor. So here it is a must one. And each doctor should have at least one or many patients. So here, if I will go here and give a name for the relationship here, I said is a family doctor. I said 4. I can give it a description here, this relationship. And here, the date and the quantity I added to the prescription, because when there is a prescription will include the date and the quantity. However, during the cell relationship, there will be a price for this. So this is how I can see the solution should be. I hope that today we practice different exercises. I really enjoy it. Somehow it was a long one, but I think that from time to time that we need to have a lab session like this that's just making exercises and practice. I hope that you enjoy it today. If you still have any question, let me answer you.
Yeah, why is it optional right over there for the doctor side?
You mean to which prescription or the family medicine doctor here?
No, the doctor identity right next to it.
Yeah, because we have two relationships here. We have is family doctor for and prescription. So to which one you are talking?
The one under the optional many, the optional many, like the
prescription. Yeah.
Is that for prescription?
Yeah. This is let's return to the requirement here. I will discuss it to you. Maybe we will change it. Every patient has a family doctor. It doesn't say that it can have many family doctors. A family doctor, so it should have only one.
Yeah.
To consult, but maybe get prescription. Might get. It not always he has to get.
Okay.
It might get a prescription from other doctors. So it might. So he doesn't have always to, maybe this patient never feels sick and never get a prescription, never get a prescription about this. You get it?
Mm-hmm.
You agree?
Yeah. But
Yeah, but
it's kind of confused the two lines. That's it.
this one you're talking
That's
about
the family doctor, I understand, but then the
yeah,
line
this is a
under.
family doctor. Yeah. We have two relationships here. The first relationship between patient and doctor, and we have another relationship between the three.
I mean,
Patient, drug, and patient, drug, and sorry, Zinnia. I said that we have two relationships. The first one is between patient and doctor, is doctor 4. This relationship tells that each patient has at most one family doctor, and a doctor should have at least one patient, and it can has more.
Okay.
This is the first one.
Yeah.
The second one talk about prescription, that a patient can go to a doctor and can have one prescription, or he will never go there and he will never have a prescription in this case. Because they said might have a prescription, they said. You got it? And maybe he went to the doctor, but the doctor doesn't give him a prescription. It's not always he has a prescription. You agree, Kevin?
Mm-hmm.
We are talking about the relationship of the prescription. So a patient can have a prescription from different doctors, not only one. So he can has many.
Yep.
And he can has no prescription.
It's optional, right? That's why.
Yeah, that's why it is optional money.
Why is there, and a doctor can give multiple prescription to multiple patient, right?
Yeah, the doctor can here also can give prescription for many patients, not only one. So it's many side from here.
Okay. That's
And the prescription can have many drugs. So this is why it is also many from the drug side.
Got it.
Go ahead, Zinian. Who do you? I think that you have a question. Zina. Yeah, go ahead.
I just help him to explain what's the cycle. Nothing. Thank you.
Yeah, thank you so much. So, do you have any more question for me today? If no question, I need 3 thumbs up to leave. Nomi, Shane, Kevin. Thank you so much, guys. I really enjoyed it with you today.